be careful here in these. These can be a little confusing. It's easy to get confused between recursive, explicit, and arithmetic and geometric. So there are arithmetic sequences, there are geometric sequences, there are other kind of sequences as well. You got to keep things straight. How are you going to do that? My advice, read through your notes once each day. Just read them. Won't take long. Just read through the notes. Keep the things fresh in your mind. So the first lesson was really an introductory lesson of the overall concept of sequences. And now we're going to deal with just arithmetic sequences here. And then the next time we meet, just geometric sequences. And try to understand the differences between the two. And that's the situation. All right, so arithmetic sequence, one where the difference of any two successive terms is a constant. A constant. Anybody remember what it's called? Common difference, right? The common difference. So that constant amount is the common difference. And you know, when they list out the terms of an arithmetic sequence, it's pretty easy to see what the common difference is. So you look at A, and we go from 3 to 7. Well, we did this when we were little kiddies, and that's a 4, obviously, and 7 to 11 is 4, and thankfully I did this one correctly. 11 to 15 is 4, and the common difference is 4, right? It doesn't take a rocket scientist. And of course, sequence can be infinite or it can be finite, and hopefully you agree that this one is finite, right? No big deal. B is kind of silly, but you know what? It is a sequence, and the 10th term will be 4, and the 50th term will be 4, and the 1,000th term will be 4, and the 1,000,000th term will be 4, and the 10 trillionth term will be 4. Let's see, what's our deficit right now? Anybody know how many trillion? All right, whatever the trillionth number of our deficit is right now, if it were this sequence, that would be 4 as well. And so the common difference, common difference is not 4, it is 0, right, on that one. Kind of boring. This one is infinite, right? Doesn't go on forever. 4 goes on forever and ever and ever. Must be a golfer, I think. Right? That's the golfer sequence. Right? You Jordan Spieth fan, Dolores? Do you even know who he is? I was wondering. All right. That's okay. Some of those guys don't even... How many of you know who Jordan Spieth is? All right, few people out there. He's a golfer. Do you know what... all right, more importantly, what company does he represent? There you go, Under Armour. All right. So a little plug for Under Armour, being they're right up there in Baltimore. And C, so what's the common difference for C? Go ahead and see if now you can use your brain a little bit. Just don't say it out loud. What's the common difference for C? Well, everybody think, because you got to be able to figure out common difference. So I just want to make sure that you know what to do to get this thing. Here, I'll give you a hint. If you were doing A, if you wanted to, you could do 7 minus 3 and get 4. If you're doing B, you could do 4 minus 4 and get 0. So on C, you could do, you know, any term minus its previous term, and hopefully you end up with, what does that give you? A negative 4.2? If my brain wants to say that. Negative 4.2. Piece of cake, no sweat. Everything's fine. Everything's grand. All right. Let's talk again recursive formula. So remember, we were talking in generalities in the first lesson. Now we want to talk about the recursive formula for an arithmetic sequence. So this is the recursive formula for an arithmetic sequence. And you in your mind need to associate the word recursive with previous term. That's the key. Recursive formula ties in a term to the previous term. So ties in a term to the previous term. So again, the formula a sub n equals a sub n minus 1, which is the... a sub n minus 1 is the previous term, and then of course you got to add in common difference, right? So you're adding in d. So a sub n equals a sub n minus 1 plus d, and away we go with our recursive formula, which allows us to figure things out if we know the previous term. All right, so if they said something like that, write the recursive formula for this sequence. You got negative 1, 3, 7, 11, 15 dots, dot, 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 dot. Guess what? Big news flash. All you need is, all you got to find is, all you need is D. All right, I was getting ready to sing a Beatles song. That's bad. All you need is D. All right. Now I'm going to stick that in your mind. All right. Beatles. Brother. Ruined our country. All right, but everybody gets all warm and fuzzy over them. All you need is D. Oh, this is terrible now. It's running through my brain. Get it? I haven't been in there for 40 years. All right, but anyhow, music. Isn't that amazing? Things that, you know, I wouldn't have heard in 40 years are still in there. And then I can't remember what I did yesterday. It's sad. All right. So D is what? 4 on this one? So if you were asked to write the recursive formula, guess what? All you do is stick D where D is and everything else the same. A sub n equals a sub n minus 1 plus 4. Nice. Arithmetic sequences. Easy on the recursive. Okay, so why don't you guys do B, and then we'll talk about C. Go ahead and do B. Right, the recursive formula for B. All right, you're done already, right? Because again, this is a sequence we've done already. We already figured out D. All right, that was tough. Surely nobody put the plus minus, did you? Right? I mean, you didn't do that, did you? I hope you didn't put plus or minus 4.2, and that's it. No big deal. Piece of cake, no sweat. Everything's grand. All right, C, determine the relationship between the slope and the graph of the sequence. All right, so this is something that is important to see a relationship here. And remember, the number of the term is like the x values. So this is which term, right? I'm writing here on the x-axis. So when x is 1, that's the first term, right? When x is 2, that's the second term. When x is 3, that's the third term. So again, this is first. This is x, right? When 1. This is when x is 2. This is when x is 3. This is when x is 4. So the sequence of the term is the x value, the input. The output is the value of the term, right? So therefore, you get the 0.1, negative 1. You get the 0.23. You get the 0.37. You get the 0.411. All right. What is the slope of the line? What is the slope of the line? Surely everybody remembers how to figure out slopes of lines. If not, shame on you. Shame on me. Shame on everything. So somebody tell me the slope of that line. 4. All right, so the slope of this thing is 4, because all you did is pick 2 clear points and figured out the vertical change, and you said it's 4, and the horizontal change you said was 1, and therefore the slope is 4 over 1, which is 4. All right, now let's write the recursive formula for this sequence, and we already have it, right? It's the one right up here in A. So what's the recursive formula? A sub n equals a sub n minus 1 plus 4. So determine the relationship between the slope and the graph of the sequence. So what's the relationship here between looking at that situation and that? Well, hopefully you can say, 4 is 4. And you can see that the slope is the common difference. The slope is the common difference. And that is the case on arithmetic sequences. The slope is the common difference. So if we were to graph B, the slope would be what? Negative 4.2, right? We'd have a negative slope, and that's fine. The lines can go up or the lines can go down, but we'd have a negative slope. This should also tell you that the graph of arithmetic sequences are not quadratic, but linear, right? And that is the case. And linear because there's a constant change, a common difference, right? Things that are linear have a constant change, right? Up 4, right 1, up 4, right 1, up 4, right 1, up 4, right 1, right? Common change and common difference, same concept. So arithmetic sequences are linear. They can be a positive slope or they could be a negative slope. They're linear, and the common difference equals the slope. So if they gave you a line and said, write the recursive formula, remember, all you need to write a recursive formula is the common difference, which is the slope. So just read the slope and write a sub n equals a sub n minus 1 plus the slope. Voila, you've got the recursive formula for an arithmetic sequence. Awesome. All right, then the other aspect is the explicit formula. Also called the general term formula, just to confuse students because we love doing that. And remember, this allows you to calculate the value of any term. Very valuable because you get the value of any term. All right, this doesn't have a sub n minus 1 because that's the recursive formula, right, with the previous term. This does have, though, a sub 1. What is a sub 1? What's a sub 1? The first term, right? So that's just the first term. Again, if you need to write yourself little notes, write yourself little notes if that doesn't make sense to you yet. So you go back and look. And of course, arithmetic sequences always have a common difference, so that needs to be in there, and so you got to have your D. So it's a sub n equals a sub 1 plus the quantity n minus 1 times D. That's the explicit formula. This will allow us to find the value of any term. All right? Now, there's a simplified version of the explicit formula, and that's what you see, for example, A, and that's what you see, for example, B. These are simplified versions of the explicit formula. So it is the explicit formula, and it's going to allow us to figure out any term. Right, so A, you need to find the 10th term, and B, you need to find the 35th term. So here, I'll help you get started. That means you're simply going to do A sub 10. All right? So go ahead and finish that out. If you're not sure what to do, you can look up here. But go ahead and finish that out, and then go ahead and do the second one, do the 35th term. Right, so if you know what to do, that's all you're doing is subbing in the value for n. Pretty simplistic. When you've got an explicit formula, let's see, 70, 140, negative 140 plus 7, negative 133. If my brain is working today, it definitely wasn't yesterday. All right, negative 133, am I good? All right. Hey, no big deal on those, right? Don't make those hard. Remember, the subscript is the term that you're looking at. 10th term, so the n is 10. Stick in 10 for the n. Figure it out. 35th term, the n is 35. Stick in 35 for the n, and voila. All right. For the sequences, for the sequence, blah, 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 13, 19, 25, 31, write the simplified explicit formula. Okay. So you got to always start with the regular explicit formula, right? A sub n equals a sub 1, right? This is explicit, plus the quantity n minus 1 times D. All right? Sub in a sub 1 and sub in D and just simplify. And you'll end up with the simplified explicit formula. Okay, so why don't you go ahead and do that. Again, you got a sub n equals a sub 1 plus the quantity n minus 1d. Sub in the value of a sub 1, sub in the value of d, simplify that little equation. And there you are. Again, if you're not sure what to do, you can look up here. Hopefully you can backwards distribute. You can either do it backwards. You can stick the 6 in front if you want, if that's going to make life easier for you. And then just clean this thing up. So what do we get? 6n plus 7. A sub n equals 6n plus 7. Luke?
So maybe it's a problem like a sub n equals 6n plus 7, and it asks us to find the determinant.
If they ask you to find what? The common difference. Yeah, well, you might not always, it might not always be clear that the common difference is the multiplier of the n. So you could always do 2 successive terms to be sure. Okay, but here it is 6. Here's normally the way you're going to get a question like this. This is normally what's going to happen. Remember, the explicit formula allows you to find any value, correct? Any term. So here's what they'll do. They'll give you the sequence, and they'll say, find the 275th term. Now, you don't want to sit there and write 275 terms to get there, right? So you would think, oh, I'm going to write the explicit formula. And once I write the explicit formula, now stick in 275 for n, right? 6 times 275 plus 7, there it is, 275th term. That's normally the way you're going to get a question like that. You follow? They're going to give you the sequence. You're going to think, oh, I'll write the explicit formula, then I'll know how to get the 275th term, and I'm there. That's usually the way it's going to go down. Everything else is just trying to get you to understand. D and all that, we're just trying to get you to understand the concepts. Okay. D. Come on, go up there. D. Last thought here. This can be a little confusing, but it's not really that bad, so hang in there. All right, the generalized explicit formula is used to find the simplified explicit formula when you know any 2 terms of a sequence. All right, so for example, let me just back up a second. If they gave you the sequence like that from beginning, you can do exactly what we just did for C and come up with the simplified explicit formula. And it's not too hard, it's pretty easy. But what if they don't give you the beginning of the sequence? Because as you see, you got to know the first term, right? What if they don't give you the first term? What if they give you like the 10th and the 11th term? What are you going to do? Well, that's what this last thing is for. So what if they don't give you that first term, but they give you 2 other terms of the sequence, and they don't even have to be successive? What do you do? Then we've got to use this formula. All right, so what is the formula? It is a sub k plus n minus k, and multiply that times d. Not terrible. Sneeze coming. Oh, sorry about that. I bet that sounds great on video. All right, anyhow. So what is a sub k? What is k? What is d? So all you need to do is think of this. Think of your terms in order. So this would be the, I don't want to say first. This would be the, all right, what do I want to say here? I don't want to say first. I don't want to say, all right, let's do this. Let's say this is the earlier term and this is the later term. The earlier term and the later term. So the earlier term is values k, a sub k. K is which term it is. Is it the 10th term? All right, k is 10. What is the value of the 10th term? Let's say the value of the 10th term is 50. So that would be 1050. What if the second term they gave you was the 15th term? Then n would be 15, and the value of that 15th term is, say, 100. So that would be 15 comma 100. Okay, that's the idea, and I'll show you that here in the example. So write the simplified explicit formula for arithmetic sequence. So they give us a sub 5 is 44, and a sub 9 is -4. Is that what that says, if I can see? All right, so let's just set this thing up and make sure that we understand. So you have k and a sub k. And the k is what value, if you're following? What is the value of k? K is the 5. It's the subscript of the first term. And what is a sub k? What is a sub 5? What's the 44? All right. And then when you do n and a sub n, then n's going to be 9 and a sub n is -4. That's what we're subbing into the formula. So now we got to sit there and we got to sub in, and this is the tricky part, and this is where we're at, and this is where we're heading, and this is where we're going, and this is what we're after. All right. First off, we got to find D. So let me use a little bit of color here. First, find D. That's what we're after. And we're going to use this formula to find D. All right, so let me see if I can make sense of this. Here, let me write the formula one more time. I know it's a pain, but it will make more sense if I do. So a sub n, oops, that's an equal. A sub n equals a sub k plus the quantity n minus k times d. A sub n, I just took the formula, that's all I did. Because again, what are we first finding? D. All right, so here's what we're going to do. Let me sub in so you keep track of things. Remember, the a sub n is the a sub 9. Agreed? The second term, the later term. The a sub k is the first term, so that's the a sub 5. Right? I'm not subbing in yet. I'm leaving that there so you'd remember and see what we did. Okay, what's the value of n? That's a 9. What's the value of k? That's the 5. And remember, we're going to find d right now. So I didn't want to sub too much at once. I could have done all the numbers right away. So a sub 9 is -4, right? A sub 5 is 44. And then you can do 9 minus 5 and get 4d. And just solve that little equation. All right, so move the 44 to the other side. You get -48. And you end up with -48 divided by 4, right? Just math, algebra. So what do you get? -12 is d. And that's what we were after first. That's what we were after first. Now we got to find the explicit formula. So second, find explicit formula. We had to get D. You got it. You can't do anything without D. All right, so a sub n equals a sub 5 plus n minus 5 times d. A sub n equals a sub 5 plus quantity n minus 5 times d. All right, so finish this thing off. A sub n, what's a sub 5? 44. And you got n minus 5 times -12. All right, so let me pause here. Don't want to lose you. See if we can finish this thing out. Okay, if you multiply all this stuff out, right, you end up with negative 12n right here, right? I'm going to rearrange things. When also you distribute the negative 5 times the negative 12, positive 60, right? Just all I'm doing is math right now. So you end up with positive 60, and you got to add that to the 44. So that's a 104, and that's the explicit formula. And that's what we needed, and that's what we were after. So a sub n equals negative 12n plus 104. All right, from that, now we can answer the final question. Find a sub 80. So again, it's a little complex there. I think the biggest thing you got to be careful of is getting now the explicit formula once you have D, right? But just follow that format and you'll be okay. All right, so a sub 80 is easy then. All you're doing is sticking in 80 for n, or yeah, 80 for n. All right. So a sub 80 equals negative 12 times 80 plus 104. And I think we end up with, anybody got it? What do you got, Keegan? Negative 8, 16. Anybody agree with that? I didn't get that. Anybody, who's got something else? Negative 8. That's what I got. Negative 856. Not sure what you punched there, Keegan, but it sounds like you got the right idea there. So the 80th term is negative 856. Okay, so let me recap this last thought here, because it is by far the more complex one. This formula here is going to allow you to get D. That's what it's after. You're after D so you can write the explicit formula. You got to have D. All right, once you have D, you can go on. This formula here then, that formula there is going to allow you to treat the earlier term as if it were the first term so that you could get the explicit formula. That's the idea. So again, you go back here. When we knew the first term and we knew D, it's easy to write the explicit formula. So we had to now find D and then treat the earlier term as if it were the first term. And therefore, then we could write the explicit formula off of that. That's the idea. And so the trick was the n minus 5d, if you want to think of it that way. Okay? So again, look at that. When you do a problem or two, hopefully you do it a couple times and it'll begin to sink in and you'll get that process down. All right, so arithmetic sequences. Remember, they're linear, right? They're linear. They have a common difference. If you were to look at their graph, the slope would equal the common difference. And so then the explicit formula, what's that going to allow you to do? Write the value of any term. They give you a sequence, they say it's arithmetic, and say what's the 4,000th term? Write the explicit formula, and then you can easily find the 1,000th term. They give you two terms of the sequence without the first. You've got to follow this last procedure. All right, work at it, and we'll pick up here on Monday.